Just take a look around you for a second. The device you're watching this on, the chair you're sitting in, the building you're in right now, all of it started out as something much, much simpler, just raw materials from the earth. Today, we're going to pull back the curtain on that incredible journey, from raw stuff to the reality all around us.
I mean, have you ever really thought about it? How does a chunk of rock from the ground become a super-fast microchip? Or how does oil get turned into the parts for a life-saving medical device? It's this hidden journey from the ground to our hands that is literally the backbone of our modern world.
And this whole journey has two main heroes. First up, you've got the geoscientists. Think of them as the explorers. They're the ones finding and figuring out how to responsibly get the raw materials. And then you've got the engineers, the builders, the creators, the ones who take those materials and transform them into, well, everything. Okay, so to really get a handle on this, we need to clear up two key ideas that often get tangled together but are actually very different: manufacturing and processing. Here's the difference in a nutshell. Manufacturing is all about assembling a finished product. Putting all the pieces of an electric car together on an assembly line. Processing, that happens way before that. It's about transforming the raw stuff into something you can actually use, like smelting the lithium ore that will eventually become that car's battery. One builds a thing, the other makes the stuff to build it with. Simple as that. So, to put a slightly more formal spin on it, manufacturing is that systematic production of goods. It's the factory floor, that whole intricate dance of machines and people working together to make everything from a massive airplane to the tiny headphones you might be wearing. And processing is its essential partner in crime. This is where the real alchemy happens. It's where we use chemistry, physics, and biology to turn what the Earth gives us into refined, usable materials. At the end of the day, processing is the crucial bridge that connects the world of the geoscientist to the world of the engineer.
All right, now that we've got those key ideas down, let's actually follow the journey of a product, right from its very beginnings deep in the earth all the way to our hands.
The whole thing really is a cycle. It all starts with acquisition. That's geoscientists finding the resources. Then comes processing, where those raw materials get refined. Next up, manufacturing, where engineers design and build the final product. From there, it's on to quality control, where everything is tested like crazy for safety and performance. But the story doesn't end there. The last step, which is more important than ever, is end-of-life management, thinking right from the start about how a product can be reused or recycled.
And that design and manufacturing part, it's incredibly high-tech these days. Engineers are using tools like CAD to build these super detailed 3D models on a computer. Those models then talk directly to computer-controlled machines and 3D printers that bring those digital blueprints to life in the real world with mind-blowing precision.
But here's the thing. This whole process isn't just about making stuff. The impact it has on our society, way beyond the factory floor, is absolutely massive.
I mean, we're talking about millions upon millions of high-skill jobs. These sectors are just huge engines for economic growth and innovation, creating all sorts of opportunities for engineers, geoscientists, technicians, you name it.
But it's not just about the money. Professionals in these fields have a huge ethical responsibility to think about their impact on the planet and on people.
And this is really the heart of sustainable manufacturing. The goal isn't just to make things anymore. It's to make them better, smarter, and way cleaner. It means designing systems that use less energy, create less pollution, and result in products that are built to last and can be recycled when they're done.
So, how do they actually measure all that impact? Well, one of the most important tools they have is called a life cycle assessment. It's basically a scientific way to look at a product's entire environmental footprint, from the very beginning when the materials are pulled out of the ground, its cradle, all the way to its final disposal or its grave. It gives you the full story of a product's true cost to the planet.
And all of this is leading to a really big idea that's changing everything: the circular economy. The ultimate goal here is to design waste out of the system completely. Instead of the old take, make, dispose model, the new thinking is about creating closed loops, where the end of one product's life is just the beginning for another. So what's next? What does the future hold? Well, we are right on the edge of another massive revolution in how we make things, and it's all being driven by some incredible new technology. People are calling it Industry 4.0, and this isn't just about making machines faster, it's about making them smarter. We're entering an era where factories are becoming these intelligent, connected systems that can actually optimize themselves in real time. And we're already seeing this happen.
Robotics are handling tasks with a level of precision that not only improves quality, but also makes workplaces a lot safer. And 3D printing is completely changing the game, letting engineers create super complex parts with almost zero waste and go from an idea to a physical prototype in a tiny fraction of the time it used to take.
But it gets even smarter than that. We're embedding artificial intelligence into machines, letting them predict when they're going to need maintenance before they break down. And on the processing side, you've got amazing innovations like carbon capture and hydrogen power that are helping industries seriously slash their carbon footprint. This is how we get to a net zero future.
So, all this leaves us with one final, huge challenge. Over the last century, we've become absolute masters at making things. The great task for the next generation of engineers and geoscientists isn't just how to make things anymore, it's how do we make them in a way that's truly sustainable, ethical, and better for every single person on this planet. That's the real frontier.